Okay, so 6.2 notes. We're starting off with a kite. That's the name of this geometric shape. It
has 4 sides.
Okay, it has, so what do we notice? It has 4 sides, okay? Okay, so this, by definition, let's put our Chromebooks away, please. By definition, is a, it's got 4 sides. What do we call a 4-sided shape?
Quadrilateral.
Okay, it's a quadrilateral. Okay, so that's in the definition. Quadrilateral. You know what's good about having a math teacher who can't spell? Spelling never counts.
Oh, that's great.
Yeah.
You are so good at spelling.
Just use the word.
But she counted it for me.
She said use the word.
All right, so what else do you notice?
No 4 angles.
It's got 4 angles.
Interior angle.
So let me, Jonathan. We could say a lot of things. This is part of the definition. I'm going to just tell you that that's congruent to, what do you think that's congruent to? The other one. Okay, and what else? And the big ones are congruent. Be careful, because I'm not saying that this is congruent to this. Okay? I'm saying that these are congruent and these are congruent. That's the definition of kites. Okay? So how would we say that?
2 pairs of congruent lines.
Okay, good. 2 pairs of congruent. So I'm going to put quadrilateral as one part of the definition. 2 pairs of congruent sides. And then I'm going to put in parentheses, not opposite. Does that make sense? So the opposite of this side would be here. Okay? We're going to have shapes where the opposite sides are congruent. This is not one of them.
Is the top angle and the bottom angle congruent?
They're not.
Then are the 2 sides between the short line and the long line?
So these angles end up being congruent.
So those 2 are congruent.
But let me tell you what we're going to jump into. Okay? So most of the time when you do shapes like this, they want to talk about the diagonals. So if I draw this one here and I draw this one here.
It's only symmetric in one way.
Okay? Yes, that's one thing. Just go ahead and draw it for a second, and then we'll talk about it. Okay, stop talking, guys, about random stuff that's not related. Stop talking, please. Okay, so one thing that we should notice about its diagonals is something about the diagonals intersection angle. This is always going to be 90 degrees, okay? So one thing for properties, diagonals are perpendicular. Okay, we know that symbol now? Okay, that means perpendicular. It means they meet at 90 degrees.
Is the symmetric thing important?
Kind of. So the other thing we need to know is that it's weird because this one is a bisector and this one is a bisector.
Yeah.
Now let's be careful. This one bisects what? The angles. So this one here is an angle bisector. Where the other one is a what? A segment. Or actually that same one is the segment bisector. But this one cuts our angles in half. So that one's going to be congruent to that, and that's going to be congruent to that. This also cuts this segment in half. So this chunk here is going to be congruent to that chunk. It's probably not after notes.
Yeah.
Okay. So I think that when I ask you to do problems and I give you a kite, they're not going to be hard today. But when we have 9 different shapes and I say, remember kites are perpendicular, their diagonals bisect or are 90 degrees, okay? Meet at 90 degrees, that kind of stuff, you're going to go, I can't remember. So what I like to do, and if you looked at my tests when I was in geometry, you would see that I drew, if it said kite, then I went off to the side and I drew a kite and I basically go, what do I notice is happening? Okay, and I can see things. You can see that this angle is not the same as this angle. Okay, you can see that this segment is not the same as this segment. Okay. Any questions on that? Okay, so next is the trapezoid. Okay, so by definition, anyone know what, really all we're going to, the trapezoid doesn't have very many properties, yeah? Only one set of, how do I do parallel?
The 2 lines like this.
Okay, it looks like 11. And they're not lines, they're what? Segments. Because lines go on forever. Okay, only one set of parallel segments. So which is here and here. Yeah, we could say it's quadrilateral. Okay. And our properties, we're not going to, well, let me tell you about the there's only one set of properties that I'm going to give you for this for now. If I extend this line out, what can you tell me about this angle? Let's go ahead and call it 1 and this angle 2.
They'll be supplementary because of alternate, no. Same side interior angle.
Same side interior says that angle 1 plus angle 2 equals 180. Angle 3 and angle 4 I'm being lazy, but I should have put an M in front of this. Why?
Measure.
Because that means the measure of angle 1. This is saying literally you take angle 1 and you take the consecutive angle, these angles are going to be 180.
You have to have the parallel line.
You have to have the parallel lines. Okay, so the parallel lines.
Because that's a transversal.
Yeah.
Transversal.
Okay, so if I went back over to my kite and I drew this out, okay, I can see that, you know, these lines aren't parallel. And parallel is what makes those add up to 180. Okay. When we get to parallelograms, we're going to see that all kinds of things are going to happen like that. Okay. And then next, this is called the isosceles trapezoid.
It has two sides at the very end of the same.
Okay. So it's what makes it isosceles is that this and this are congruent. Okay.
Which means that the angles are probably clear on the bottom, so base angles are clear.
Yeah. Yes. So let me tell you how I always thought about this. Really, an isosceles trapezoid is a triangle with its top cut off. Same as a regular trapezoid. It's just a triangle with its top cut off. Okay. And if you think about this going up, then it would follow and it would still be isosceles. The base angle would be congruent. That angle would be congruent to that angle. And oddly enough, we have 2 sets of base angles in a trapezoid. What's the top base angle on a triangle? Never mind.
Be confused.
Okay. So let's talk about the definition of isosceles trapezoid.
Quadrilateral.
Okay, it's a quadrilateral. And this, what do you think the name of this chapter is?
Quadrilateral.
Mm-hmm.
What?
This chapter's, well, it's actually polygons because the first section's got, but it focuses on quadrilaterals and they threw the polygons in
Mark
it.
said quadrilateral triangles.
Did I say triangles?
No, Mark said quadrilateral triangles.
Yeah. He regrets what he said. Okay, I'm listening. What else is the definition? Only one set of congruent sides. Last time we said congruent segments, but I like sides better actually. And only, sometimes instead of using the word only, they say exactly one set.
Wait, couldn't square be oh, never mind.
Square cannot, because the square has two sets of parallel sides.
Square could be a kite though.
No, it can't.
But like a square can be a rectangle.
Right, we'll get to all that.
Rectangles, but rectangles are not squares.
That's just called triangle.
I hated when.
What?
Properties, base angles are congruent. Okay, so the mistake that people will make is they'll say, oh, I have a trapezoid, base angles are congruent. It's only isosceles, right? Also, this follows any rule that the regular trapezoid followed. So let's go ahead and name this 1 and 2. Be consistent 4 and 3. So angle 1 plus angle 2 equals 180. Also, angle 3 plus angle 4 equals 180.
Because of additional.
You're right, because of same side interior angles. Let me ask you this. How do I know that all 4 of these angles add up to 360?
Because they both add up to 180. That's the same thing.
So 4 minus 2 times 180, right? So this adds up to 180. What is this at? All the interior angles of this add up to 180 because it's 4-sided. Okay.
Wait, how much does all add up to?
Because of number of sides minus 2 times 180.
Oh, I'm counting the.
Yeah.
Do you not count those in it?
The diagonals will only come into play when you're talking about the diagonals. So we kind of imagine them not being there unless I said, let's talk about that diagonals.
Because I was gonna say that's just 360 in the top.
Yeah.
Right there.
Let me say something else about the diagonals. So if I wanted to construct a kite, okay, it would be really hard to construct a kite like on a large field, like this shape. So what you do is you make this, you figure out this length, and then if you figure out this and this one here, and you can get this to be the perpendicular bisector, then you can make the kite. That's how you would actually do that, okay? You wouldn't figure out this length and then try to figure out what this angle is here. It would look awful, I promise you. What you do is you just make this 90 degrees, and that's how you would construct it. One other thing that I need to tell you about isosceles triangles, which are not, it's not obvious when we look at it, but if I were to make diagonals, this is isosceles trapezoid, okay, and I did an awful job of drawing that, but the diagonals are, they don't cut each other in half, but what do you think is true about them? They're congruent. They equal each other. So if I said A to B and, you know, this length here is the same as that length. Okay. Yeah.
Okay, so if we're doing a problem, please let tell you if it's an isosceles trapezoid or not.
Yeah, so it would, if it didn't tell you it was isosceles, they could say, here's a trapezoid, but they could tell you that this is 3 and this is 3, and then you know it's isosceles. Okay, or they could give you tell you the base angles are congruent, then you know it's isosceles. So they have to give you some piece to tell you that it's isosceles. Okay, first questions here. Okay, so name the shapes. These are definitely kites.
Wait, that's the actual shape.
That's the actual shape name.
Is there like some fancy name?
Yeah, the fancy name is kites.
Nice.
That's so
Okay, Rico.
That's funny.
Gee, yeah, rhombus. Why isn't it rhombus? Rhombus has.
4 seconds from the other side.
All right.
That's a square.
So I honestly, when I look at these, I visually kind of like looking at them and figuring out what's going on. And you know that certain properties exist. Now, if it was a proof, I would have to say which property I'm using. Like I'd have to say diagonals are 90 degrees or so forth. This doesn't say prove anything. It just says find the unknown angles. Okay. So I know I have a kite. I can tell you that angle 1 in this first one is what?
90 degrees.
90 degrees, because it says in kites that the diagonals are perpendicular. So that tells me that angle.
So it's T. T is 90.
T is actually the point.
Oh.
Angle 3, what do you think that is?
35.
Okay, 35. And how would you say that that's 35?
Definition of isosceles.
If I asked you to prove it, we would probably, if I asked you to prove it, we might go into that this triangle here is congruent to that triangle. Okay. And then we could say by corresponding parts congruent, corresponding parts for congruent triangles are congruent.
Just say CPC.
Cats, puppies, cats, turtles, cats. Okay, we would be able to prove that, but it's not asking us to prove it. And then finally, angle 2, which I think takes a little bit more work, but isn't necessarily hard, is 55. How did he get that? Not Mark. How did Mark get it? Hope.
You add 90 and 35 and then subtract that from an 80.
Okay, so we're using the triangle sum theorem.
Yes.
Okay, the next one.
Oh. It's another kite.
2 is 32.
Okay, how do we know that angle 2 is 32?
Yeah.
Because it cuts that angle in half, so then both sides should be the same. Angle 1.
Is,
40.
give me 1 second.
Everyone is 48. Oh my god.
I heard angle 1 is 48. Confirmation.
That sounds right. Let me calculate.
I don't know.
That's right.
Oh,
32
yeah.
plus 90. It's not, wait.
32, 90.
90 is 1 12.
No, it is not.
Yeah.
It's 58.
Plus
It's
90
90.
is 58.
It's 58.
58,
I
yeah.
do 50.
I'm done.
Okay. So again, even though it didn't ask us to find it, we had to use the fact that that's 90 degrees right there. Okay. How many of you? How many guys? How many of you, instead of adding these two and then subtracting 180, realize that these two had to add up to what?
90.
90.
You could do it that way too. That's what I did.
Okay.
That's what I did. I just told Travis so that he was doing it that
It's
way.
equaling to like 90 plus 33
Well, we can do it either way. That's what you just said.
But I'm saying you could just say 90 minus 32 because we know that 90 is left between these two.
Rachel just did that on that.
That's confusing. Pretend like I didn't just say anything.
Rachel completely on accident just shouted out 90 minus 32.
Name the shape and find the unknown angle. So Hope's question was, will they always tell you the name of the shape? No, but they're going to make it pretty obvious what the shapes are.
Yeah.
What are these shapes? Isosceles, trapezoids. isosceles trapezoids means what's true about their angles?
180.
The two angles add up to 180, and their base angles are congruent.
180.
Okay, so tell me what this angle is here.
50 to 45.
What?
45, because these two add up to 180. Angle P is 45.
And then they all add up to 860.
Q is 135.
So you could add them all up to 360 and go that way, but those angles are congruent, so that makes that life a little bit easier. This angle here would have to be what?
133.
133. How do you know that?
Because subtraction.
Supplement your angles.
Good job.
47 is the other one.
I'm listening. 40
47 is 7. C. S.
S. Angle S is 47.
Angle T is 47, and then angle U is
133.
He said angle U is 133. Why am I unhappy with him saying angle U?
Because there's two angles for angle.
Angle RUT. And I could have just wrote them in there, but I'm not very good at drawing that small. Any questions on those? Again, when in doubt, draw something off to the side and kind of ask yourself, why is that working?
What should the people
Clear it out.
I don't know if I can tell you this story, if you can handle it, but my daughter went to camp this summer, and she came home from camp one day and said, I learned a valuable lesson. When in doubt, let it out.
What can't you do?
Anybody find that funny?
No, I don't.
It's true,
though.
Go
When in
pee.
doubt, you just try everything out.
Oh, okay. All right. Here's the $1 million question. What type of camp was it?
cook camp?
Okay. I'll ask again at the end of the period if you can think about it. When in doubt, let it out.
Anger management.
Probably. Military camp.
I thought it was LGBT camp.
What?
What?
What'd you say, Goldie?
Brian, what did you say?
What's it?
Oh my God.
All right, so let's keep going. Given isosceles trapezoid, where the given is the diagonals, what is the value of A? So what do we know about these? And honestly, when I look at this, problem, and they're telling me that this length here is this A plus 13, and this length here is 2A plus 1. So, thank you. So when I look at it, and I have to set up some kind of equation for it, do the lengths add up to, like, there are certain things that just always happen. Adds up to 180, adds up to 360, are congruent. I don't know, two of them equal the other, something. There's some kind of relationship, okay? But there's only so many relationships that we have, where they're either equal to each other or congruent, or they add up to something. Segments, what do segments never do? They never add up to what? 360. So when I taught geometry before, a lot of times kids would tell me segments add up to 360 or segments add up to 180. Okay, so they start making up things that don't even make sense in my mind. Okay, but they're just grasping at straws. When I look at this, even though we just said the rule, what's true about the diagonals? I mean, just looking at what do you think must happen? They're congruent. And if you were watching me take this test, you would see me hold my hands like this. Okay, and then what do you think I'm going to do with my hand? I'm going to pick it up, and I'm going to go like this, and I'm going to kind of okay? Or a piece of lead, or you would see me doing this, okay? And I go, oh yeah, they're totally congruent. Okay?
So then you do something.
So again, right now, this may not seem very hard, but when we have 9 shapes and nine different rules, some are true and some are false, these become very challenging.
I wouldn't be able to tell the difference.
A is congruent to 14. Oh, I didn't know you put it up there.
Okay, A equals 14. Trapezoid mid-segment theorem. Okay, anybody know what a mid-segment is of a trapezoid?
The midpoint of a segment.
Okay, okay, it's not. You guys, when I'm lecturing, if we're talking about random other stuff, I mean, it feels rude to me. Okay, it's also doesn't help out some of our classmates who kind of need to focus. Okay. So we've seen midpoint, okay, but this is a mid segment. So what is it? It's a segment that cuts something in half. So if I were going to cut this thing in half, okay, there might be multiple ways of cutting it in half, but what it means is that we're going to cut it in half this way. And if I cut it,
Yeah, that wouldn't be congruent.
okay, so now let me show you why it's the mid segment. It's cut so that this and that are congruent. It's cut that and that. So it's cutting the sides, the non-base sides in half.
And wouldn't the angles be the same too?
I'm sorry?
Angles for A and C and B and D, your thing too?
Be the same. What do you mean?
They add up to 180.
These, I mean, yeah, it still follows that rule that these add up to 180, these add up to 180. But that does, so the mid segment. Now, anybody want to guess how long this is? The mid segment.
Oh, is it?
It's not possible to determine.
Average of
Wait a
A,
sec.
B, and C.
It is the average
Of the other two.
of the other two.
What?
So
I'm a genius.
AB
It's 3.
plus CD divided by 2 equals, we'll call this, I don't know, EF. So it's the average of the,
No, we didn't get that one.
Why did you get that, Maddox? Because, I mean, if you look at it.
Max is smarter than you.
I
Ben,
know
stop.
to the next problem.
Okay, you guys, that was a very good question, and then diarrhea of the mouth took over. Okay, Maddox?
I mean, I just saw it, and I saw that half of it was just, if you took this, it's like the same between these two. So I just thought average between it.
So I think what he's getting at is the part that this is missing is same as the part that this one has.
Yeah.
Okay, and the part of this one's missing is the same as what the part of this one has. Or I said that backwards, but
I just looked at the next problem.
okay. So let me ask you this: if I made a mid segment of a triangle,
Up and down.
it would still be the same way. I could extend this out. What is the value of the top of the triangle? Why is it 0?
Because there's no length, it's just a point.
There's no length between the 2 points. So you could actually do the same thing with a triangle, except the mid-segment triangle equals what?
Why?
It goes double 0.
So
Half of the base.
half of the base. The mid-segment of a triangle equals half the base, because the base plus the top is 0. So it's the base plus 0 divided by 2. Okay? The next one here. So they were really weird in how they asked this question, in my opinion, but we're going to go with it. So they said that they gave us that the mid-segment's 25. Okay. I'd like to be able to find this length and find this length. So let's start with the bottom. What is this length here? This length equals 20.
4/5 of XY.
XY is 25.
So it tells us XY is 25. So it says 4/5 of that. That's 20. Okay. And this is how they try to kind of trick us, is that they gave us in a sense, the answer. So somebody set up the equation for this.
You could multiply 25 by 2.
20 plus
55.
X, I'm listening,
Over 2 equals 25.
equals 25. Good. Okay, so the formula says the top, or the bottom and the top added together. Yep, this one here. So she went ahead and called this X. Okay.
25.
Now some of you can probably maybe would skip this step.
Yeah,
I would literally just go 25 times 2.
There's a trick to doing this, so you don't need to.
It's 30?
It's 30. Now,
Yeah.
I want to point something out that when we don't write stuff down, that's when we say things like, it's 45. No, it's 35. No, it's 45, right? Where we're off by 10, right? Because we make those little mistakes. Writing it down, you won't make those little mistakes, okay? So I highly recommend that we're writing stuff down when we do these problems, okay? Any questions on this? So let me clarify. This assignment's due by this Sunday. Okay, the assignment based on this online. Okay, I haven't printed out a sheet for you. I'll try to have a sheet for you tomorrow. Tomorrow is a work day. Okay, I'll try to have a sheet with you, and it'll clarify all that extra stuff that we did in the iReadies and stuff. 4 more iReadies are going to be due. Not this Sunday, not next Sunday. Probably next Sunday, roughly. Should I say it again?
The Sunday after Thanksgiving.
Let me sit down for just a second. Okay, so we have,
No, next Sunday.
so guys, I'm not done talking.